You're right there.
Yeah, moving along well. So the sixth output that I want. So with my fifth output, I was saying I have these, weld nuts here. So I have a fixed fastener situation where these bolts are going into these nuts. They have to pass through these holes to get to these nuts, so you torque them down. In this case, I have a floating fastener situation. So what that means is that instead of having the bolts, screwing into a weld nut, this bolt passes through two clear holes, and then at the bottom of that, I'm putting on, a loose nut at the bottom. So in this case, I'm doing that for my bottom panel of my platform. And I have 8 of these whole hole pairs, and I just want to be able to slide an M6 bolt through these two 7.5 millimeter bolt holes. And you'll also notice that one of them is pretty short and the other one's pretty long. So when we use our virtual clearance measure, which is the measure we're going to use in this case, all that you're doing is you're selecting a group or a set of concentric at nominal, typically concentric anyway, usually nominally concentric holes. So these 3 are the 3 holes that I want my M6 bolt to pass through. Now you might be saying, but there are only 2 holes in this picture. Well, this hole is pretty short, so I'm saying probably angular variation, I'm not super concerned with it. But this hole is much longer, and so there's a much higher chance that the location of this top spot is different from the location of this bottom spot. And if I want to make sure that this bolt is going to pass through all 3 of these holes and, probably end up being torqued down so its face is being pressed against this, maybe I want to check 2 spots of the same hole. And so that's all I wanted to show you guys with this one, is that I'm checking 1 point at the center of this top yellow panel, and then I'm checking 2 points to represent that whole axis, so that if there is some angular variation there, I am kind of trying to take into account with this.
Yeah, and if you wanted, you could have 2 points at the top and bottom of the yellow.
Yes,
and
exactly.
Just 4 points in this measure.
Yeah.
But typically, like sheet metal parts, if they're 7/10 thick, we don't waste our time with the thickness of that part.
So again, the primary inputs are just going to be a set of points representing the holes the pin or bolt must pass through. And this is best used for validating clearance holes for floating fasteners, like I said. Let's go into the model, and we can open up the help file for this one as well, because the help file has another image that can help you visualize what's happening here. So I'll open up that measure, and then I'll click this help file button again. So if I slide down here, this is the situation we are in. We have 3 holes, and we're trying to see what is the largest pin that I can pass through those 3 holes when they're all kind of moving off of nominal. So that blue circle represents my pin that I can fit through, and then I have these 3 gray circles that represent those 3 holes that are varying. Someone might ask this. You can also do this with pins. So I could select several pins and it'll tell me what size hole I would need. I would say that's a much less common situation for someone to be in, but not impossible. So just point that out. It also can do a series of pins and it'll return to you what size hole you need. But in this case,
internal or external calculations.
Yes, internal or external calculation. So back to my model. If I go ahead and I cut that cross section we were just looking at, should be now through those holes. So here's one of the, I believe this is going to be the hole I'm looking at. So you can see I have 3 of these holes. Each of those holes is 7.5 millimeters in clearance. So nominally I can fit a 7.5 millimeter bolt through there. And then you can also see that I have a spec limits here. My lower spec is set to 6 millimeters because that's that M6 bolt that I'm trying to shove through. Upper spec I set to be 10, kind of arbitrary number. It doesn't really matter too much.
And just so you know, that current number is going to be whichever, if in your list up there, whichever hole's the smallest, that's what the current number is going to read.
Yes.
Because that's the virtual clearance.
That's a good point.
It just happens to be all 3 of his holes are 7.5, but if you had 2 of them 7.5 and 1 7, well then even nominally the virtual clearance is 7.
Yep. And so now if I deviate and we select this current button on each build, we should see this number drop below 7.5 as, you know, the positions of those 2 holes change, and also the sizes of those, you know, holes change. But we want to make sure that it stays above that 6 number is our target.
Yeah, and it's really cool because you can see the yellow winking the white up at the top, as, you know, due to tolerances and moves.
Yep.
Assembly variation. Yeah,
that's because these are clearance holes, so we aren't using these to locate. Similar to my side panel, these also have just a 4-way and a 2-way, you know, a tighter hole and a tighter slot that I'm using to locate it. And then the idea is that I'm then driving all the variation to, you know, this spot here, and I want to make sure that my assembler can then get this M6 bolt through here no problem. So that's virtual clearance. We got one more measure to go. So I'll zoom out one more time here.